Hi class. Let's look at this example. The population P in thousands of Montgomery, Alabama from 1970 through 2005 can be modeled by this quadratic function. P of t is negative 0.07 t squared plus 4.37 t plus 135.18, where t is in years after July 1st, 1970. I'm going to jot that down so I remember it. T equals 0 on July 1st, 1970, the middle of that year, 1970. So that's the way we've defined our independent variable t. Our dependent variable, capital P, is the population in thousands. Now notice that that leading coefficient of the quadratic model is negative. So that means that the graph of this model would be a downward opening parabola. We don't know where that turning point, where that vertex of the parabola is. So, on our model domain, we don't necessarily know whether that turning point is in play. Our model domain, I'm going to jot this down too. Our model domain are the years 1970 through 2005. 1970 is 0, and 2005 is 35 years later. So that's the interval from 0 to 35. Those are the kind of t values where our model is defined. Basically, we're being told that the model was generated from data in that 1970 to 2005 range. So let's make some predictions. Let's talk about how this model behaves. According to the model, what was the population of Montgomery on July 1st, 1970? Well, July 1st, 1970 is our 0, so we're looking at what is P of 0. When t is equal to 0, plug that into the model. This you can actually do mentally very easily. You can think, if I plug 0 into that model, I'm looking for the p-intercept of this model. If I plug 0 in for t, that first term is going to be 0. Plugging t in here and multiplying by 4.37, that's going to be 0. The answer is going to be 135.18. Remember that on a quadratic model, the coefficient c, the constant term, will be the output when the input is 0. So that's 135.18 thousand people. Now, if we didn't know that, if we didn't see that, it's okay. We need this model in our calculator anyway, so let's turn our calculator on, put the model into y1, negative 0.07 t squared plus 4.37 t plus 135.18. And now I'm going to double check my data entry just to make sure that that's okay. Anytime I type anything into the calculator, I double check. Minus 0.07 x squared plus 4.37x plus 135.18. Looks great. And if I just mechanically plug 0 in for t, in other words, compute y1 of 0 on the calculator, I should get 135.18. Perfect. Part B, what does the model predict for the July 1st, 2010 population? 2010 is 40 years after, the middle of the year 2010 would be exactly t equal 40, 40 years after July 1st, 1970. So we're calculating P of 40. Notice that right here, we're being asked to extrapolate with our model. We're going 5 years beyond the stated model domain. So we're in uncharted territory here. We're 5 years into the future of the model. If this trend were to continue, this is where the model would say the population would be going on July 1st, 2010. So what do we get for that? Let's plug on the calculator. That would be y1 of 40 rather. y1 of 40. And that's 197.98. 197.98 thousand people. According to the model, what was Montgomery's maximum population between 1970 and 2005? That's on its domain. What's the maximum population? Well, let's first of all just graph this model on that interval, on the interval from 0 to 35 on the model domain. So x min 0, x max 35, and run zoom fit to let the calculator take care of the p-axis, the output axis. We see that model increasing at a decreasing rate, and then I saw it turn, and now it's decreasing on the other side of the vertex. It's decreasing at an increasing rate, and the vertex is going to be the highest, the maximum population, the highest that that population goes. Let's calculate it. Calc maximum. Left bound, well, right there is fine. Hit enter. That's definitely to the left of the maximum. For right bound, I could cursor over there to the other side, or I could just type the endpoint of the interval that I've graphed here. That would be 35. So I'm just going to, for right bound, I'm going to type 35. That's all the way over to the other side of the screen. And then hit enter to guess. And I get a maximum population at time t equal 31.21, the maximum population is that output coordinate, 203.38. Let's see, part C is asking for the maximum population, so that answer is 203.38 thousand people. Part D is asking us in what year did that maximum population occur. So we're getting two answers for the price of one computation here, because t equals 31.21 years, 31.21 years after 7/1/1970. That's when that maximum population occurred. What year would that be? Well, if we take the 1970 and add 31 years, that would take us to the middle of the year. That would take us to the middle of the year 2001. Right, 2001, and then the 0.21, so really I'm just adding 31.21, and that's 2000, I don't know why I'm having so much trouble with this one, 2001.21, and that 2001 is the middle of the year, 2001.21 is less than half a year beyond that middle of the year, so we're in the year 2001.